Because this is part 2 of the notes that we took yesterday. It was on logarithmic functions and their graphs. Okay, so we left off on log base 3 of 81 is equal to 4. How do you rewrite this so that it's the base? It's an exponential function.
3, 4 equals 8.
Perfect. Is it true that 3 times 3 times 3 times 3 4 times gives you 81?
Yes.
Yeah, 3 times 3 is 9, 9 times 3 is
27.
7 times 3 is 81. Okay, very good. Let's look at the second one. How do you rewrite that as an exponential function? Perfect. Okay, kind of died down towards the end. It's just a loop. Okay, so you start with your base. Your base 2 to the power of 3 is equal to 8.
It's just like a cycle.
3 to the power, the base 3 to the power of 4 is equal to 81.
Promise it's just like a cycle.
Yeah, it is a cycle. Okay, that's your trick. You can think about it obviously in the way that I showed you here. Okay, I convert it into words, so I convert from a log to an exponential. But if you prefer the little loop trick, with practice you'll get it. Okay, it'll stick in your head and you won't have to even think about it anymore. But the base goes in the bottom, is raised to your exponent, and is equal to y. Okay, so if I want to turn my exponential function into log, what do you do first? Log. Very good. Gotta write log. So log base 8 of 64. Okay. Perfect. Very good. And in this case,
I did that right.
so this time you're gonna do 8 equals to 64. Base 8 to the power of 64 is equal to 2. Okay, let's do the next problem. That one, work out with your partner. All right, guys, so what's the answer?
4 equals 3.
Perfect. Okay, I want to point something out to you. Notice how the 4 is in the bottom, okay? The 8 is in the bottom, so you have to make sure that it's not on the same line as the rest of log 64 equals to 3. Okay, the 4 is in a completely different line than the other one. All right, are there any questions? Okay, and this is very easy again. 4 to the power of 64 is equal to 3. Let's go to the next slide. The next slide says evaluating logs. I think I skipped one. All right, guys, so continuing from the next problem over, it's now we learn how to convert from exponential to log and from log to exponential. Now we're going to learn how to evaluate log functions, okay? So the first thing you're going to do is you're going to rewrite the log function with the y. So instead of f of x, you're going to just write y. So y equals to log base 2 of 32. We need to rewrite it as an exponential function. How would we rewrite that function as exponential?
Now 1.
What's the base? 2. So 2 to the power of y is equal to 32. So 2 to the power of y is equal to 32. You can tell the circles are going in a different direction. Okay, the loop is the same.
So it's just reversed?
Yeah, just because it's the way that it's written. Okay, it has a y now in front of it. All right, so you need to make the bases the same. How can I what do they have in common? 2 and 32. 2, right? So how can I rewrite 2 to give me 32? So 2 to what power equals to 32? Okay, some students said 6, 5, 4, and 3. Okay, so what's 2 times 2? 4. That's twice. 2 times, and then 4 times 2 is 8, so that's 2 to the 3rd power. 8 times 3 is, 8 times 2 is 16. Then the last one, 16 times 2
32.
is 32. Good. So your final answer is that 2 to the power of 5 is equal to 32. Do you see that? Okay. On the other side, you're gonna leave 2 to the power of y. Okay. Same. So I rewrote the right side as 2 to the power of 5 is equal to 32, and then I left the left side the same. Are the bases the same?
Yes.
Yes, the 2's are the same, so you drop everything that's in the numerator, not the numerator, in the exponent down to the bottom. Exactly, it's our tetras again. So therefore, y is equal to 5. The other thing I wanted to point out is that you can check your answer by substituting in y equals to 5, wherever you see a y. Is it true that 2 to the 5th power is equal to 32?
Yes.
Yes, we just checked that, okay? We just found that out. Very good. Let's go to the next slide. Okay, you and your partner are going to solve this function, okay? You're going to use the previous example as your guide. We replaced f of x with y, and we start with our base of 4. So 4 raised to the power of y, good, is equal to 2. Okay, so the second step is to rewrite them with the same basis. What do they have in common? 2 and 4 have in common? 2. So I'm going to rewrite these as a base of 2. What do I need to raise 2 by to get 4?
2.
2. So it's going to be 2 squared gives you 4. Okay, and you're left with the y up here on the top. You can't drop it. And what is the exponent of the second 2? 1. Good. So it's actually 2 to the power of 1. Are your bases the same? Yes. So those drop down, and you're left with 2y is equal to 1.
Miss.
Have we solved for y? Nope. You're going to divide both sides by 2. Perfect. So your final answer is y is equal to 1/2 or 0.5. Okay. Is it true that 4 raised to the power of 1/2 is equal to 2? How do you know that? You're in the calculator, so if I pull up one of your screens, it'll show? Oh, no, well, now I'm going to do it. Okay, so please do that. Go 4 to the power of 1/2 and see if it's equal to 2.
4 to the power of 1/2. Yes. How do you do that?
So 4 to the power of 1/2 is equal to 2. Okay, that's how you're going to check your answers. So you're going to write y equals log base 3 of 1. Okay, to rewrite it as an exponential, you're going to write base 3 raised to the power of y is equal to 1. Can I rewrite these as the same base? Not really, okay? Like the least common factor that they have between them, or least common multiple, is 1. They're both prime numbers, so you can't do anything more than leave it as 3 to the power of y and 1 by itself, okay? Your question is 3 raised to what power gives me 1? 3 to the power of 1 is 3. 3 to the power of 3 is 27. How about 3 to the power of 0? Is that true? 3 to the power of 0 is 1. So y is actually equal to 0. This next example has a fraction in it, but don't let it worry you. You have log base 10 of 1 over 100.
Ooh, okay.
Okay? So you're going to rewrite it as y equals to log base 10 of 1 over 100. So you should be thinking right now of how to rewrite it as an exponential function. What is your base? 10. So you're going to have 10 to the power of y is equal to 1 over 100. Okay, is it possible to make these have the same base, 10 and 100?
Yes.
Yes, okay, so what do I have to rewrite? 100 becomes 10 to what power?
10. No.
10 times 10 would be like a million. Okay, so 10 to the second power. 10 times 10 gives you 100. Now, that you have the same bases, you have to have the bases on the same line. Okay, so I have to actually move.
This one up.
Yeah, I have to actually move 10 squared up to the top. Okay, so I really have 10 to the power of y is equal to 10 to what power? Negative 2. Okay, perfect. When you move a decimal, when you move a number with the exponent, you have to switch the sign. All the time, every time, no matter which direction you go. If it was in the top, you have to bring it to the bottom, you have to switch the sign. Okay, that's something that you learned last night, okay? So are the bases the same?
Yes.
Yep. And so what are you left with?
Y equals -2.
Y equals to -2. Perfect. How can you check your answer? Okay, you're going to plug it in. So I want everyone to do that right now, please. Go ahead and check your answer. You're going to say 10 to the power of -2 is equal to?
1 over.
Your final answer.
Smart.
The calculator is smart. What's as smart as you are? Okay, so just like Gael got for an answer, it is 1 over 100. Okay, for the last slide, we want to talk about the properties of logarithms. Okay, so log base of a of 1 is equal to 0 because what is a to the 0 power? Any number raised to the 0 is always 1. So you have a 1, which is exactly why you have that in your log. The second property is log base a of a is always equal to 1 because what's a to the power of 1? Any number raised to the power of 1 is always itself, okay, or the same. You're going to put a. These letters mean a number, okay, so it's really like 7 to the power of 1 would be 7. 100 to the power of 1 is 100. Okay, students get confused in algebra because we have all these letters in there. Okay, but all it really represents is a number, just a general number. We just don't know what number it is. It could be different each time. Okay, if I have log base a of a, those cancel, and you're just left with x. If you are taking a to the power of log base of a, you're also just left with x. They cancel each other out. If you have log base a and log base a on the same sides, on opposite sides, they cancel, and you're just left with x is equal to y. Okay, as your, what is it called, your ticket out, I want you guys to work on the 1, 2, 3, 4 examples. Okay, I'll give you the answers before we,